States of matter. Matter is made of tiny particles separated by distances with nothing between those particles, which basically means the particles make up the mass of a substance, and that distance refers to taking up space, hence the definition of matter. The particles are always in motion, and the amount of space between the particles vary with temperature, volume, and pressure. Most solid materials have specific types of geometric arrangements in which they form when cooled, giving them a definite shape and a definite volume. The type of geometric arrangement formed by a solid is important. Chemical and physical properties of solids often can be attributed to the type of geometric arrangement that the solid forms. Solid particles are closely packed together, and even though the particles do not look like they're moving, the molecules are vibrating in place. The particles in a liquid move more freely than the particles in a solid. They have enough kinetic energy to slip out of that ordered arrangement of a solid. However, the particles in a liquid have not completely overcome that attractive forces between them, and this causes the particles still to cling together, giving liquid a definite volume, but an indefinite shape. Gases, these particles are far apart, and their attractive forces between the particles they can easily overcome. Therefore, gases do not have a definite shape or volume. Gas particles can spread far apart or even contract to fill a container that they are in. Solids, liquids, and gases are the three familiar states of matters, but none of these are the most common. The most common state of matter in the universe is plasma. Plasma is matter consisting of positively and negatively charged particles with an overall charge being neutral because equal numbers of both charges are present. Stars, including the sun, contain matter that is in the plasma phase. Plasma exists where the temperature is extremely high and can also be found like in lightning bolts, neon, and fluorescent tubes. The kinetic theory is an explanation of how particles of matter behave. To explain the behavior of particles, it is necessary to make some basic assumptions. The kinetic theory is as follows. Number one, all matter is composed of small particles such as atoms, molecules, and ions. Number two, these particles are always in constant random motion. And number three, these particles are colliding with each other and the walls of their container. Try to visualize a room of ping pong balls. Imagine each ping pong ball is a particle in constant motion. This helps you visualize kinetic theory by imagining these balls bouncing and colliding with each other in a room. Look down at the tabletop you're sitting at. The atoms in that tabletop are held tightly in place by the attraction between the particles. This attraction between the particles gives the table a definite shape and volume. However, the thermal energy in those particles causes them to vibrate in place. Thermal energy is the total energy of materials particles, including kinetic, which is its vibrations and movement between the particles, and potential, which are the resulting forces that act within or between those particles. Now, you usually use temperature as a term to explain how hot or cold an object is. In science, temperature means the average kinetic energy of particles in a substance or how fast those particles are moving. On average, molecules of frozen water at 0 degrees Celsius will move slower than molecules of water at 100 degrees Celsius. Therefore, water molecules at 0 degrees Celsius have lower average kinetic energy than the molecules at 100 degrees Celsius. Knowing that particles move faster and separate as temperature rises, this separation of particles results in an expansion of the entire object known as thermal expansion. Thermal expansion is an increase in the size of a substance when the temperature is increased. There are many examples in the world around you. For example, have you ever noticed the seams in a concrete driveway or a sidewalk? A gap is often left between the sections to clearly separate them. These separation lines are called expansion joints. When concrete absorbs heat, it expands. Then when it cools, it contracts. If expansion joints are not used, the concrete will crack when the temperature changes. Now, normally, substances expand as temperature rises because the particles move farther apart. However, the one exception to this rule is water. Water molecules are unusual in that they have highly positive and highly negative areas. When water freezes, the water molecules orient themselves according to charge, and empty spaces occur in the structure. These empty spaces are larger in ice than in liquid water. So actually water expands when going from a liquid to a solid state. And solid ice is less dense than liquid water. And this is why ice floats on the top of lakes in the winter or on the top of your refreshing glass of water. Now, what happens to a solid when thermal energy or heat is added to it? Think about adding an ice cube to your hot cocoa. The particles in the hot cocoa are moving fast and colliding with the vibrating particles of the solid ice cube. The collisions of the particles transfer energy from the hot cocoa to the cold ice cube. The particles on the surface of the ice cubes now begin to vibrate faster. Those particles collide with the transfer energy to the other particles, and soon the particles of ice have enough kinetic energy to overcome the attractive forces. When they gain enough kinetic energy, they slip out of their ordered arrangement and they turn to liquid and the ice starts melting. This is known as a melting point, or the temperature at which a solid begins to liquefy. The amount of energy required to change a substance from the solid phase to the liquid phase at its melting point is known as the heat of fusion. Now, while the melting point is the temperature at which water goes from a solid to a liquid, freezing point is the opposite and is when a liquid transitions to a solid. Freezing occurs when heat is lost from an object, which causes the molecules to slow down and form tighter bonds. Water freezes at 0 degrees Celsius or 32 degrees Fahrenheit. This temperature is the freezing point, or the temperature at which water freezes. When particles move fast enough, they can escape the attractive forces of other particles and enter the gas state. This process is called vaporization. Vaporization can occur in two ways: evaporation and boiling. Evaporation is vaporization that occurs at the surface of a liquid, and it can occur at temperatures below the liquid's boiling point. A second way the liquid, of course, can vaporize is by boiling. Unlike evaporation, boiling occurs throughout a liquid at a specific temperature depending on the pressure on the surface of the liquid. The boiling point of a liquid is the temperature at which the pressure of the vapor in the liquid is equal to the external pressure acting on the surface of the liquid. Heat of vaporization is the amount of energy required for the liquid at its boiling point to become gas. Condensation is when a gas changes into a liquid through a cooling period after water has been evaporated into the air. The air cools down and the water molecules clump together to form tiny droplets of liquid water, like forming clouds. Anything that flows is a fluid. That means both gas and liquids are fluids. Buoyancy is the ability of a fluid to exert an upward force on an object immersed in it. If the buoyant force is equal to the object's weight, the object will float. If the buoyant force is less than the object's weight, the object will sink. In the 3rd century, a mathematician named Archimedes found that the buoyant force on an object is equal to the weight of the fluid displaced by it. For example, if you place a block of wood in water, it will push water out of its way as it begins to sink, but only until the weight of the water displaces equals the block's weight. When the weight of water is displaced, the buoyant force becomes equal to the weight of the block and it floats. Look at the picture of this boat. The empty hull of the boat contains mostly air. Its density is much lower than the density as if the boat were solid. The lower density of the wooden boat and air combination is what allows the boat to float in the water. Try to explain why a boat that takes in water might sink. A Swiss scientist named Daniel Bernoulli studied the properties of moving fluids such as water and air. According to Bernoulli's principle, as the velocity of a fluid increases, the pressure exerted by the fluid decreases. One way to demonstrate Bernoulli's principle is to blow across the top of a sheet of paper. The air above the sheet of paper is moving faster than the air under the paper, creating a low pressure area above the paper so the paper will rise. This principle is used when designing wings for an airplane. A British scientist named Robert Boyle described a property of gas is if you give gas particles more space, they will hit walls less often and gas pressures will be reduced. According to Boyle's law, if you decrease the volume of a container of gas and hold the temperature constant, the pressure of the gas will increase. The behavior of weather balloons can be explained using Boyle's law. Weather balloons are used to carrying sensing instruments to high altitudes to detect weather information. The balloons are inflated near Earth's surface with a low density gas. As the balloon rises, the atmospheric pressure decreases and the balloon gradually expands to a volume of 200 times its original size. In the 1600s, a French scientist by the name of Pascal discovered a very useful property of fluids. According to Pascal's principle, pressure applied to a fluid is transmitted throughout the fluid. For example, when you squeeze one end of toothpaste, the toothpaste expands out the other end. The pressure that you put on it transmitted through the toothpaste. Pascal's principle had been used on hydraulic machines. If you've ever seen a car raised with a hydraulic lift in an auto repair shop, there's a pipe that's filled with this fluid which connects these cylinders together. When the pressure is applied to the small cylinder, it's transferred through the fluid to the large cylinder, and because that pressure remains constant throughout the fluid, more forces are available to lift that heavy load by increasing the surface area. With a hydraulic machine, you could use your own weight to lift something much heavier than you are. Have you ever noticed an aerosol container, the warning that always says keep away from heat? Well, what happens if you heat an enclosed gas under pressure? The particles of the gas will strike the walls of the container more often, and because the canister is rigid, its volume cannot increase. Therefore, the pressure inside is going to start increasing. If this pressure becomes greater than the canister it can hold, it will explode. This same principle is seen if you've ever watched a hot air balloon being inflated. Now, while it doesn't explode, you can see that the gases expand when they are heated. Because the particles in hot air are further apart than particles in cool air, the hot air is less dense and begins to rise, lifting the balloon. Jacques Charles was a French scientist who studied gases, and according to Charles' law, the volume of gas increases with increasing temperature as long as the pressure does not change. And the reverse is also true. The volume of a gas shrinks with decreasing temperature. So the next time your parents ask why you're having a bag of popcorn, just tell them you're experimenting with Charles' law. You just want to see what is happening, right? Time to show what you know.